Okay, hello students. Now we will continue the work power energy chapter. In the last session, we have discussed until the blast of the spring block system. Now we will start the spring block system. So let's start. Spring block system. Now, spring block system is a one that is the spring. This is a one that the spring is attached to one end. With the one end, and here the block of mass M is attached. Okay, and if we apply an external force F, the object moves to same distance as applied force, but the spring will move in the opposite direction because it acts as a restoring force. So it is known as Fs. Now we will see what is the work done. Work done. Here are two gases by the spring and by the F external. Now by the spring means the work done is the work done is F dot S. So the minus theta is equal to 180 degrees, and here F external means theta is equal to 0 degrees. So here it is negative, but here it is positive. W is equal to minus Fs. Here it is Fs. Now Fs means here the force is K into X. F is equal to K into X. But the distance is increasing. So we can write that W is equal to half Kx square. It is for the external force. Now for the spring force it is minus half Kx square. Okay, this is the concept. Now we will discuss a problem. Okay. First, there is a case that when length of spring changes from xi to xf, then what is the work done? It is F xf square minus xi square. W is equal to half into K into xf square minus xi square, because it is final minus initial. Okay, this is the same as the kinetic energy one. We will listen about kinetic energy in the later one. Okay, let's solve a problem. Okay, first problem. The work done by spring, work done in externally by F external on spring for extending x naught is half is W naught. Then find work done in further extension x naught. Here we want to substitute the values here, but we don't know what are the values. Let's see that xf is equal to x naught plus x naught gives rise to x naught, and x initial is equal to x naught. Now work done. W is equal to half into k into x square minus xi square. This is the final W dash, and W naught is equal to half into k into x initial square. Let's divide this and get the y. So W dash by W naught is equal to k into xf square minus xi square upon, here k will also cancel out, and xi square. Okay, let's substitute here 2x naught whole square minus x naught whole square upon x naught whole square. That's common x naught square, and here it is 4 minus 1 upon x naught square. So W dash by W naught is equal to this. So W dash is equal to 3 of W naught. This is the one. Okay. Now first copy this. We will discuss the next problem. Okay, let's discuss the next one. Okay, the second problem of spring lock system. There is a spring of K value 100 Newton per meter, and it acts on a block of mass. They have the mass because here we don't take the mass, and it acts upon a force. Here x naught is equal to 10 centimeters. Now first case, work done by spring force when the block attains equilibrium. Okay, we want to find out the what is the F spring. W spring is equal to minus of half into K is 100, and it is 0.1 if you convert it into meter. So it is 1 by 100. So it will become W spring is equal to minus 0.5 joule. This is the spring force. Now the second one is W net on block when it attains Vs max speed. Okay, when it attains max speed, we want to find out W total. So it is W force into x naught. W F is equal to F into x naught. It includes, but there is no force. So we will take K into x naught Okay, here K into x naught into x naught. Okay, we will grab this and we will do here. to force is F into X. So 100 into X naught force is 1 by 100. So it includes 1 joule. Now we want to sum it. W net is equal to W force minus W spring. Here it is negative, we get the negative one. So 1 joule minus 0.5 joule. So W net is equal to 0.5 joules. Okay. Now let's discuss the next problem. The question is so easy. Initially the block is at rest and it acts upon a force of on a spring constant 100 Newton per meter and it elongates into 110 centimeter. First we want to find out the W spring when the block attains equilibrium. At equilibrium the length is this. So we want to substitute here, then we will get the work spring. When W net on block when it attains maximum speed. So W net is equal to F into X naught. That means P into X naught into X naught. That includes 100 into 100. So it includes 1 joule. W net. This minus this. That includes force minus of 0. So we will get the 0.5 joules. Now we will discuss the dependence upon frame of reference. 1. Okay. Dependence on frame of reference. So work done depends upon the frame of reference. Work done depends on frame of reference. Okay. Now because this is a block or this is a bulb. Here there is a person and the question block mass. First, W with respect to the bus. W with respect to the bus is 0 because with relative to the bus the block is at rest, and with respect to the ground it includes F into S plus S naught because force into bus plus force of the block. This includes the work done changes with the frame of reference. First with respect to bus it is 0 and with respect to the ground it is F into S plus S naught. First copy this, then we will discuss the conservative and non-conservative forces. Okay, let's discuss the conservative and non-conservative forces. Okay, conservative and non-conservative. First of all, what is conservative? The work done in any path is same. That means the conservative forces are depends upon the initial and final position. Work done depends upon initial and final positions. Here, the non-conservative forces means it depends upon the path followed. Work done depends upon the path followed. Depends upon the path followed. Here, the sum of the individual work done is equal to 0. Sum of individual work done is 0, and here work done by individual forces is not 0, and work done by round trip is 0. That means I find initial to final, final to initial. So it is circular path. So the distance traveled is 0. As I said, sum of individual work done is 0. So it is equal to 0. The third one. W done by round trip is not equal to 0. Now let's draw the graph diagram. It is at A and it is at B. Okay. Now it goes a straight line initially, and then it takes a circular one and a zigzag straight. 1, 2, 3. So W1 plus W2 plus W3 equal to 0. And here W1 plus W2 plus W3 is not equal to 0. Now let's discuss the examples. The examples are gravitational force, electrostatic force, and so on. Gravitational force, and electrostatic force. And here the work done is by the frictional force. Okay. Now let's discuss the differences, conservative and non-conservative forces. Here work done depends upon initial and final position. Here the path followed. Sum of individual forces is 0. Sum of individual work done is not 0. Work done by the round trip is 0 and here not 0. So the path followed in A, B and W1, 2, 3. So W1 plus W2 plus W3 is equal to 0. And the examples are gravitational force and frictional force. And here the examples are frictional force. Now first copy this, then we will discuss the problem associated on this. Okay, let's solve the problem. Now the problem is, first problem on this one, a body of mass 0.3 kg is taken up an inclined plane of then allowed to slide down the bottom again, and it has a friction, that is mu is equal to 0.15. I want to find out W F, that means applied. The second one is W gravitational, third one is W frictional. As we know earlier, the work done by the gravitational force round trip is equal to 0. Here it is not equal to 0. Round trip. Here it is saying for upward. Now the graph, the diagram will look like this. The object of mass is taken upwards, applied, and mu is equal to 0.15. H is equal to 5. L is equal to 10 meters. Now for the upward journey, here mg, and here this mu mg cos theta. Here it is mg sin theta plus friction. So for the W1 upwards, that means for the gravitational force, Wmg is equal to, here downwards, here it is negative because the displacement and the Wmg in opposite direction, minus mg sin theta. Okay, now here it includes this value is 0.3 into 10 into sin theta. Here it is theta. Sin theta is equal to opposite upon hypotenuse. It includes 5 upon 10. It is 1 by 2. So Wmg is equal to minus 1.5 joule into 10. So it will become minus 15 joule. Now the W friction is equal to, here downwards as well as the sign is negative. So minus mu mg cos theta, minus mu mg cos theta. Mu is 0.15. So we will take 10 by 100 into 10 into 15. Here this is 0.3. 3 by 10 into cos sin 60 means cos 30. That includes root 3 by 2. So 10 cancel 5 by. So W friction is equal to 3 root 3 upon 2, and it is negative. Now the W force applied, it is W force applied as well as the distance into cos. That means F external into S, and this same direction. So Wf applied is equal to mg sin theta plus mu mg cos theta into total distance. So Wf is equal to 18.897 joules. If you substitute here, now it is for the upward journey. So we have completed this. For round trip it is equal to 0. Now let's solve the total round trip for this. For downward it is plus. Okay. Now copy this, do the downward one. Okay, now let's do the downward one. Now downward. Downward means it's the same. Wmg is equal to mg sin theta. That includes 0.3 into 10 into 1 by 2 into 10. That includes 15 joules. Wmg. And for the friction, W friction is equal to mu mg cos theta into S into cos 180. Because the friction is downwards, upward, because it is going downward, the friction is upward and the displacement is also downwards. It is cos 180. Mu means 15 by 100 into 3 by 10 into 10 cos 30. Cos 30 means root 3 by 2 into minus 1. So 10 and here 3 by 10. Okay, 3s are 20s are. So it includes, okay. So it includes 9 upon 2, 20 into root 3 upon 2 minus. Here also it is 9 upon 20 minus into root 3 upon 2. So for a total round trip, you want to plus. W total is equal to 2 times of 9 by 2 into root 3 by 2 negative. So W total is equal to minus 9 root 3 upon 2. So this is the rougher round trip. Now let's discuss the kinetic energy one for this section. The next section we will discuss the potential energy. Okay, first copy this. Now let's see for the kinetic energy. Okay, kinetic energy. Kinetic energy. Kinetic energy means it is due to the motion. The energy applied to the body for the virtue of its motion. So it is motion, so it has velocity. So Ke is equal to half mv into v. So Ke is equal to half mv square. Now the following points are, it is always positive and it depends upon the frame of reference. It depends on frame of reference. Now we have a relationship between Ke and momentum as Kp is equal to square root of 2 km. Now we will see how they came. Now Ke is equal to half m V into V. Okay, on the both bottom and down we will multiply by M. So Ke is equal to half into mv whole square, because mv into mv upon mass. It includes p square upon 2m. So this is the relation. Now let's see some problems and we will end this session. Okay, let's see some problems. And one more, we have the work energy theorem. We will discuss the work energy in the next session. Okay. Now first problem. First, V initial is equal to V naught and V final is equal to V naught plus 2. Ke final is equal to 2 times of Ke initial. Now we want to find out V naught is equal to dash. Here saying that there is a block that has final velocity 2 increases by 2 times of initial velocity and its Ke becomes twice. So what is the original speed of the block? First we want to write the kinetic energy when K is equal to 2 times of K final is equal to K times 2 times of K initial. Okay. Now we know the formula. Half m into V final square is equal to 2 into V initial square. Okay. V initial square. Now m cancel and V final is V naught plus 2 whole square is equal to 2 V naught square. By solving this we can get, so we can solve now. V naught square plus 4 plus 2 2s are 4 V naught is equal to 2 V naught square. So 4 V naught minus, or you can take this one to there, V naught square minus 4 V naught plus 4 is equal to 0. By solving this you can get, so we want to get the 4 into 1. Okay, if we solve this you can get the initial 1. So by using b square minus plus or minus b plus or minus square root of b square minus 4ac upon 2a, you can get that it is 2 into root 2 plus 1. Okay, this is the 1. Now let's see the next problem. Okay, the second problem, the mass of the bullet is 50 grams and its speed is 200 meter per second and the thickness of the soft plywood is 2 centimeter, and after going to the soft plywood it comes out with the n% of V initial. Sorry, it is K final velocity, final kinetic energy. It is K initial energy. So we want to find out the V final is equal to dash. Now we want to substitute here half into mvv square here we have n is equal to half m v final square. So from this you can get that this one mass v bullet v final is equal to root n of, because it is n percent, so n by 100 of vb square, here vf square, so v final is equal to root n upon 10 of v bullet. This is the one. So if you want to substitute here, then substitute. That is your one. Now let's see the last problem. Okay, we will see the last problem. The last. Ke of particle is increased by 300%. Find in percentage increase of momentum. So first Ke initial is equal to 100% and Ke final is equal to 400%. It is saying that it is increased by 300%. So the initial is Ke 100%. Now we are okay. Percentage of the momentum. Now K momentum is supposed to start to root K. So P percentage of P is equal to square root of E2 minus square root of E1 upon square root of E1 into 100. Here it is 20 minus 10 upon 10 into 100. And by 10 it is 100%. Percentage of momentum is 100%. The simple one. Okay? Okay, first copy this, we will decide whether you can continue or not. Okay students, we will discuss the work and energy theorem in the next session. Okay, that's all for today. Thanks for watching this video. Bye bye.